Hello, everyone. My name is Eladin Bar. I'm the CEO of Robotics, and thank you for joining me for this quick demonstration of Engage K12, our online learning platform for robots. In this demonstration, I'm going to walk through the different screens and different lessons, and I'm going to show you how we teach and engage students by using these platforms. Let me start by sharing my screen over here. And we can delve right in. Here we go. Obviously, not Zoom. Okay, so Engage K12, you can access that by going to engagek12.com or engagek12.robotlab.com or click on the lessons or Engage K12 logo on our website. On the platform, you'll find hundreds of different lessons divided by either the robot, by the subject, by the age group, or by the standards. You can search by any one of these. We also encourage our educators to create their own lesson, submit their own lesson. We can add that to our platform. Once you're logged into the platform, the first thing that either a student or a teacher sees all the different classes that they are assigned to. A class is a collection of different courses and lessons that is assigned to a specific group of students. So in each group of students, each class, we get a different group of students. Students can join themselves by using this dedicated link that is available only for this class. And teachers can create as many classes as they want and bring as many students as they want together. So basically, they can separate their Monday 9 a.m. Session from their Monday 10 a.m. session from their Monday afternoon session by creating different classes and assigning different courses and different lessons to these classes. As a teacher, I can see the progress of each one of the lessons that I assign to my students. I can make them inactive or active, or make sure that they are self-paced or guided, which means that we allow teachers to use a flipped classroom or a guided instruction. It really depends on the way that you want to run it as an educator. Now, when we're talking about lessons, what are we talking about? So I want to show you a couple of examples of how lessons work and what we're doing with the robots in these lessons. So every lesson has several steps, and we start all the steps by using the curiosity, the natural curiosity. So in this lesson, we want the students to master the law of sine and cosine. So we start with observation. We want them to understand why do we even need that? Where does it come to play? And as an educator, you always get teaching tips for each one of them. You're getting choreograph files. And in this file, you basically going to make the robot raise his hand and lift a hat. And we want to spark the curiosity for the students. We want them to ask, well, how does the robot know how to raise the hat? And what's the distance that the arm should be at? And they realize that this is actually a triangle, and they can calculate that. So then we take them to a safe simulated environment. In the simulated environment, they can actually, you can see that here, they can actually measure everything. They can move the point, they can see the different values, changing on the graph, on the online calculator over here as we play with the simulator. And the idea here again is to make sure that students master the subject while working with a safe environment that is safe for error. So no one will laugh at me if I make a mistake, and they can actually plan where they want the robot to pick the hat. So let's assume there is a hat over here, where that should be, what should be the angle of each one of the joints, assuming that we know each one of these body sections. And obviously, you submit your answer, and the teacher can see the answer. The same thing, although of cosine, same set of online simulators. But again, the idea here is to let students explore that. Once they do that, we want to take them to ArcoScience, which is again just another part of that. And once they are ready, we take them to a full life simulation. So in this simulation, as you can see, I can move it around and so on. In this simulation, the students get a random hat, which they can also change. And in this simulation, we want them to actually calculate what's the angle and test it. So they have here, the different angles, the different thing, and we ask them just one thing. So what, in this case, the shoulder to the figure point length. So what should be the length over there? Okay, and they can select, different combinations, which will obviously load, different hats and so on. They can also see the plane itself, so they can calculate, they can count the centimeters on this plane and make sure that they actually do the math correctly. And once they are done, they can obviously test it from every angle. So let's say I'm putting here just one as an example, and I can check it. And yeah, it seems you made a mistake. Good. Try with a bigger number. So obviously I didn't do the calculation over here, but let's say 3, check. Yeah, also wrong. Okay, fine. I'm not a good math experience right now, but I think I can solve this equation based on the law of sine or law of cosine and figure out what's the answer. And once they are ready to go on the real robot, they can actually go right over here with the composer from Zora and basically program the robot to move its arm, and they can control the joint and make the actual motion as they need to to achieve. And once they are done, we want them to answer a few questions about what they learned. And again, this gives the teacher the ability to understand where the class is, and in terms of material understanding and so on. And it will reflect on the teacher's dashboard. So this is an example, really quick example for one quick lesson. Another example for another lesson is, for example, slope of a line with 2 points, where again we want the students to understand how slope, the concept of slope, actually makes sense. So we start with observation. We show them robots playing soccer, and we ask them how do the robot know, where they're, where to kick the ball to. We want them to explore, so we give them some coordinates on a plane here, and again they have the virtual simulator. Okay, so this is the goal line. This is the line the ball travels on. This is the slope, and obviously they can change the slope and see how changing the slope changes, the place where the robot is going to hit the ball. And as a teacher, you can actually change the point that you want the students to hit. And based on that, they need to solve the equation and figure out what should be the equation that will take their ball from this point to that point. So basically, it's building a linear equation from 2 lines. If they don't know, we also provide them hints, and they can actually get the real data based on this. Once they did that, we take them again to a full, full simulator where they can actually see for themselves. And let's say over here, I'll put, I don't know, 0.3 as an example. Let's hope that there'll be a better, guesstimator over here. And you can see I run the simulation, and the robot just gonna walk over, approach the ball, align itself with the right angle based on the 0.3 angle, and we have here, and actually, almost, I missed it. But anyway, the idea again is to give the students the ability to practice in a safe environment where everything, no one will laugh at them if they made a mistake, and they can keep practicing. So if, for example, I'll do I don't know, 0.5, then I can actually reset it. I can actually try again with a different set of values. And then again, they need to run it on the real robot. They go either by using Choreograph or by using Zora, and they just program the real robot to go over and kick the ball. The teachers get, in the teaching tips, the teacher get the actual printout, so they can print a whole field with the grid on it, something that will look very much like this grid. So the students can have the real measurements on the floor. And like everything else, once they are done, we want to make sure that they understood the subject. So we ask them a few questions. So again, the teachers will be able to get a glimpse of where the class is and what the students know and how they master the subject. So this is a quick example on how a lesson or a couple of lessons work with Engage K12, with online programming, with the robots, and how the different steps will make the students understand and be engaged with subjects that otherwise are just too abstract to understand. Thank you for your time. I appreciate it. And if you have any questions, we are always here, happy to answer any question. If you need a login, a temporary login for Engage K12, we can provide that as well. You can create your own by just going to Engage K12 and click on one of the lessons and just create your own demo account. It will assign a few lessons for free for you. Thank you, much appreciated. Have a good one.